we're going to begin some modeling. We don't want to look at that. Okay, great. Right, so here's AnyLogic's opening screen. I'd like you to open it up. If you have a model from yesterday, open, close it, okay? When you call up AnyLogic, some of you may get to a splash screen that looks like, oops, I don't want to do that one. I want to go to this one. Sorry, not that. That's not what it looks like. It looks like example models, something like this. If you get to this, you can minimize it using that. Okay, to get to this screen here. Do you see this? Do you have this this up? Okay. So, ladies and gentlemen, what I'd like to do now is to lead you through an example that's going to that's also going to be based on a network-based infection, but we're going to take this in a somewhat different direction. Okay, so what I'd like you to do is to first create a model. So we'll create a new model here, and this is going to be called SIR open population. Okay. And I'm going to go put it in a appropriate place for this boot camp. Okay, and here we go. There we go. Boom. Okay.
Model time seconds.
Sorry?
Model time is seconds.
Oh, thank you. Model time is days. Thank you. Thank you. So, this is the result of an old dog and new tricks. So this introduction in that entry screen of the time units is new, and I often miss it. If you miss it as well, you'll want to go to the model as a whole and select model time units here, and you will be able to then correct that. Okay. Okay. So, ladies and gentlemen, I'd like now to go create an agent class. How do I create an agent class? Can anyone remember where I would go to do that from yesterday? Where would I go?
Right click on
Yep.
your model, go new.
Good.
Agent.
New agent type, that's right. So we'll create a person here, okay? And I'd like you now to be able to go and go to person, and we're going to do something a little bit more advanced from yesterday. We're going to go down for person, we've called it up, and I'd like to go down to pictures area. So Kurt, you'll want to circulate here to the pictures area in the palette. So remember, to add things into our model, into this canvas, we want to make sure that the right thing is showing, person here, and you're going to drag in a person figure into person, okay? So there's a small figure. Incidentally, you can define your own images to be added within this context if you want to use your own images. For example, some of my students had a most unkind model that was a model, I think it was an infection model, where all of the persons were shown with my face on it. and I was getting infected many times over. Okay, so here we have person. Okay, now let's rehearse the basics again. How do I add a population of people? Can anyone tell me here?
Drag person.
Yeah?
Into main.
Good. So we drag person into main. So remember, we have to go down main, right? And let's go here and drag person into main. So if I want to make this a population, what do I need to do? First of all, I should change the name from person. And suppose I could type it right now, but suppose I somehow mess up and I don't type it. Where can I change it? In the what? In the properties, right? Okay, what else do I have to do to make this a population? Yeah, make it a population of agents. Suppose I want this population to be able to be resized from experiment to experiment. I don't want to be hamstrung and only have the same size population. I want to be able to change that from experiment to experiment. What do I need to add? A parameter. Okay, good. So we're going to add a parameter here. Okay, great. And this parameter is going to be called population size. I'm trying to build up the muscles you might use pretty frequently with these models so that these things, if not second nature, at least familiar. So I've added population size. Now, what do I need to change to reflect that this is a population of people? So you either have 0 or 1 or 2 or 3. What do I need to do? Change the what? The type indeed to be int. Okay? Okay. Now, I'll make the default value of this be say 250. Default value be 250 people. Okay. Great. And now, is that all set, or is there one more thing I still have to do?
Let's go back to population.
Indeed. Yeah. It's all nice and good to call population size, but right now it's full of sound and fury and it signifies nothing. In order to make it operational, in order to make it change something, I need to go to population and say this is the population size. Okay? Population size. Hey, there we go. Population size. Okay? Great. Great. Okay, and suppose that we further want to set it so that this population is spread out over space. Where do we go for that? Where do we go for that? We want to make them appear at a randomly chosen X and Y location. Where do we go?
Go to population, initial location.
Yeah, exactly. Initial location. And we'll put in a formula here that it's going to run. For each successive person in turn, it's going to run this formula. Uniform from 0 to 500, okay? Okay, 0 to 500, okay. So let's run this model now. So X and Y, how did we get to there? We're in the population. We went to initial location. You might have to expand it. And you go to X and Y, saying in the specified node X and Y, and it'll be located there. Is that okay? People ready to run it? Those who are ready can run forward, leap forward. Who would like me to show something more? So in short, we added a population size. We made this an integer of size 250. Okay? Size 250. Do you see that? And then we went to population, and we made its initial number of agents be population size. We made it a population of agent, and we made the initial location be between 0 and 500. So what is this doing? For each successive person in turn, it's going to be drawing their X location from this 0 to 500 in their Y location. When it creates them, it's going to use this and draw it from 0 to 500. By the way, one thing I haven't shown, but I could, and we may come back to it, is this formula here. This could refer to characteristics of that person, like their income, or their sex, or their home location, or what have you. In other words, this could refer to their characteristics. It doesn't have to be determined with no reference to their characteristics. That's very powerful. It can be drawn from a database where they live. Their GIS location can be drawn from a database. You know, the home of this farm, or the home of this park, or what have you. Okay, Okay, who would like me to show something here? Okay. Who would like me to show something? Anyone? Okay, should we run it? What do you think we'll see? What vista will lie before us? Oops. Okay, there we go. Great. Okay, now suppose we wanted a population size of 1,000. Let's call this simulation pop size 250. Suppose we wanted a pop size of 1,000. How do we do that? Just building those muscles from yesterday. Remember that population size is a parameter. It encodes an assumption. Parameters encode assumptions, and they provide a way of communicating those assumptions from the point of creation to the thing that holds the parameter. Here, the thing that holds the parameter is main. And what's the thing that creates main, that specifies the values of main's parameters? It's the experiment. Thank you. Yeah, okay, good. Okay, so ladies and gentlemen, how do we add a new experiment?
Copy experiment.
Okay, yeah, we could copy. I like that. Copy. That is the nice virtue. Irene's point is the nice virtue of copying all its settings with it, which is kind of nice. Sometimes we like that, particularly if we spend a while setting that carefully. Carefully specifying the moose population appropriate or whatever. We could copy it. I'll make it pub size of 1,000, and we'll make it 1,000, and we will run that, and here we'll have a denser population. Ladies and gentlemen, why did it change this to be population size 1,000? I had it originally as 250. You'll notice it's not bold here, and then I changed it to 1,000. Why does it change this to be bold?
It's not the default.
It's no longer the default value. It sort of highlights, hey, you've changed this one. So if you have a big list, you can quickly see which ones you've changed for this experiment from the default value, which is kind of, well, in Kurt's generation, the term for that, I believe, is sweet. Okay. Okay. So here we go. Here we have 1,000, right? Okay. Okay. So, ladies and gentlemen, we've rehearsed a number of the things we learned yesterday. These aren't small things. These are like your day-to-day bread and butter. So rehearsing these is well worth it. But now we're going to rehearse from a more uncomfortable time, yesterday afternoon. We're going to impose a network on these. And this network will be initially a distance-based network. Ladies and gentlemen, we're going to impose a distance-based network on these individuals. How are we going to do that? Anyone remember? Where do we go for the network? Connections, okay, and that's for a person, so there's connections. We're going to do something with connections. Does anyone remember what we did with their connections, the connections in person? We actually went down, remember this thing here, draw line connecting agents? Remember that? Okay. So we could do draw line connecting agents, and we could do draw behind agent or draw on top. We're going to do draw behind agent. Okay? So if they're in a network, we are going to be able to draw a line between them. Okay? Okay, so that's good. But what we want to do now, ladies and gentlemen, is we're going to actually set this up to do multiple types of networks, okay? So what we've done here is we basically said, if there's a network, draw a line between the agents, okay? But now we're going to go impose a network. Where do we do that in any logic?
On main.
In main, indeed. Okay, so we're going to go to main. And where do we go in main? Well, we go down to the space and network area. Okay, now, you notice there's a network type here. And we're going to say that the network type is distance-based. And you notice that we have a connection range here specified of 50, okay? We are going to change this, ladies and gentlemen, to instead reflect a connection range which is 75 right now, okay? But I'd like to suggest, ladies and gentlemen, that you do the following, and we're going to go in a different direction that we did yesterday. So this is in Maine. Ooh, wait a minute. Yes, it's Maine I'm selecting, okay, as I hoped. Oh, very important point about AnyLogic. This is actually a really useful factoid. You can select things in AnyLogic in two places. You can select something up here and see it in the properties window, or you can select something over here in this window here, this projects window. You can select it either place, and that means you can actually expand in this properties window to see all the things in Maine, for example, and we can select them there. So either place we can do our selection, okay? So in this case, I had Maine selected, and I went down and I set it to be a distance-based network, okay? A distance-based network with connection range 75, okay? Are we ready for that?
What is that 75? Is that like grids?
That's actually, well, we're going to come back to this in just a minute, so I welcome that question. It's what I described yesterday is that the 75 means 75 of, as measured by this spacing here. Each of these is 5, each of these small cells. The larger one is 25, and so it's going to be 3 of these. Now, as we saw yesterday, for those who are here, there's actually a correspondence that you can set up here between physical space and this kind of virtual space. Do you remember seeing this yesterday? And if you click on this, you can say ruler length corresponds to so much physical space. Do you see that? And it's exactly to this issue that I'm about to address, okay? But first, I want to make sure that the basic model is running, and then we will go in that direction, okay? So ladies and gentlemen, we should be able to run this model now. What does that mean, a distance-based network? Does anyone remember? What does that mean, a distance-based network?
They are within a certain distance, though.
Yeah, a given pair, A and B, are connected if and only if they lie within a certain distance. So if we consider their positions, if that lies within 75 units of space, they'll be connected, otherwise not. Okay? So let's run this thing. Okay? Here we go. So you should see something like that. And Krugerian assistance is on its way if it's needed.
Somebody has a very big network.
Okay. That's good.
Yeah, with 1,000.
Okay, there it is with 1,000. Yeah, it exhibits a measure of density. Okay, so ladies and gentlemen, but suppose right now, I mean, this is a little bit overwhelming to see, and I'd like it to change it so that the distance used is actually something we could set in the experiment. So in the experiment, we could say use this distance, that one. None of this having to go back and go to Maine and go down and change this thing where it says 75 manually. Let's not get it there. Let's make it able to be set by each experiment. It can just choose the experiment what distance to use. How would we do that, ladies and gentlemen? How would we do that? What would we add to make it so that the experiment could say what to assume? Just like we did it for the population size. Each experiment can say a different population size. What was it that allowed us to do that? It was the fact that population size was specified as a what? Parameter. So we want to make a parameter in main for the connection range. Can we do this? Okay, how are we going to do that? From whence do we add a parameter? From the agent palette, right? Right? Parameter. So we'll take a parameter, and whither does it go? It goes into main. Okay. Okay, and we'll call this connection distance threshold. Okay. Okay.
The alt tab or the control space autocomplete.
Sorry?
Have you showed them?
I did yesterday. I emphasized it early and I emphasized it often. Yeah. And I noted that the TA load, the load on the TA and the time delay for the class is probably reduced by a factor of 4 or something by judicious use of autocomplete. Or at least the TA load.
Especially long names like distance space threshold.
Yeah. Yeah. Okay. Fair enough, Kurt. Okay. So point well taken. Okay. Connection distance threshold. Okay. Doesn't leave much to the imagination. Sometimes when you get older, your memory goes. Connection distance threshold. Okay. Ladies and gentlemen, so we're going to make the default value of this be 75. Okay. That's just if the experiment doesn't say anything, it'll use 75. If it's different from this, it will change that color to indicate it's been changed for the experiment. Connection distance threshold. Now, how do we actualize that? How do we operationalize that? Right now, it just says connection distance threshold, but it's not actually enforcing that. How do we enforce it? How do we make that the distance threshold that's actually used? Where do we go and put it?
In main.
In main. Yeah, in main. What am I doing? In main here, okay? In main, we'll go down to properties, and where it said 75, what shall it now say? Connection, and this is where autocomplete will be your friend. Control space, and there it is.
On a Mac, it's option space.
Option space, thank you.
Yeah, usually.
Right. Yesterday I showed them where you can set that in when you want. Yeah. Okay. So, ladies and gentlemen, now we can set this. Now, I want to draw attention to something, though. Okay. Take a look at this connection distance threshold. You'll notice that it's currently a double. Okay. But you'll notice that there's another option here to specify it as a length. Do you see that? So you could actually specify a unit and a value. Now, the full significance of this is not yet obvious, okay? But I'd ask you to turn it to length and leave these guys by default, okay? Are we okay with that? Okay, now, ladies and gentlemen, I would like you to go to your experiments here, and you'll notice now that you have in the experiment an ability to specify this distance threshold. After all, that's why we added it as a parameter, so each experiment could specify it, right? But look at this. You can choose in each experiment what units you want to use. So we could specify it in meters. You could specify it in feet. You could specify it, if you so felt inclined, in yards. In short, you can choose your units with which you specify this quantity from according to each experiment. So we could go specify this here, and here we'll have these quantities. And we could then specify it in entirely different units. For example, I could specify it as 75 kilometers, for example. In which case, we'll have more or less total total connectivity. I could specify the contrast as 75 feet, which is considerably smaller and will have less connection here, okay? So we have the option in AnyLogic. This is a very notable feature of specifying units at the time when you're going to be specifying that value. You can choose your units with which to describe it. You're not shoehorned to always describe it in the dominant unit. Okay? So, so here, by choosing, the key thing there is that we chose that parameter to be not just some old average double precision value. We actually chose it to instead be a length. And we're going to come back to this, because later we're going to choose things, for example, to be times, a duration of time, the duration of Kurt's infectiousness, for example. That could be specified as a time parameter. Okay? Okay. So that's worth noting here, ladies and gentlemen. Okay. So this is good, but my purpose in showing you this model is actually to allow us to see several different unit types, or several different network types. Okay? And I would actually like to show you a different way of undertaking the very common task we've always undertook one way, including for this lesson. So, ladies and gentlemen, I'm talking about the task of laying people out on the screen. Okay? Laying people out visually. So, I would like to go back to person, to population here, excuse me, to population, and I would like to go where we have never gone before. Okay? I would like to eliminate the X and Y reference here. And I would like to change, it's going to be an unhappy camper. Just the best way to do it is to do at the agent animation location. Just choose this. You don't have to actually delete them. At the agent animation location. Are we okay with that? Ladies and gentlemen. So where did I go? I went to the population. I scrolled to initial location at the agent animation location. Are we okay with that? Okay, now, suppose we were to try to run this now. What we would see is most unhelpful. Why is that? Does anyone remember? We have a population that remains of size 250, but where are all of that population? Yeah, they're stacked in a most uncomfortable fashion. Okay, so ladies and gentlemen, we are going to accomplish this in a different way. We're going to go to main, and once you're down main, you can scroll down to the space and network area. Okay? So going to main, once you're down main, you can go to this, you can scroll down to the space and network area. Are we okay with that? Okay, and now, ladies and gentlemen, see where it says layout type? Do you see that? I would like to change that to be random. Are we okay with that? Change it to random. And now I'd like you to rerun this model. We've just secured a random layout by virtue of having said layout should be random there. Okay? Layout should be random. Okay? Alternatively, let's do this. Choose another layout. Notice, by the way, before was user defined. I'd like to say arranged. And now let's run that same thing again. They stand like a phalanx of TAs, ready to serve. Okay? Ladies and gentlemen, I'd like to again go back to main, and I'd like you to set a different layout. Yeah, I'd like you to set a spring mass layout. Here, in this case, the layout will will reflect the connectivity. Okay, so people who are connected together will tend to be placed sooner. Now, in this case, we'd really want to specify separately a separate connectivity. I think we'll come back to that one just because it will require a little bit of futzing on our part. The one I want to settle on for the moment is what's called a ring layout. May I show that to you? Let's do a ring layout. And I'd like you to run that. Okay? Ladies and gentlemen, there's a ring layout. These people are arranged in a ringed fashion. Are we okay with that? Do you see that? Okay, does anyone need Krugerian assistance?
I just have a question. So, and maybe you're gonna talk about this, but was that kind of arrangement, is it useful for? Yeah,
we're going to use it to illustrate some features and just now. I'm settling on that because it'll be very useful for our purpose. Okay? Now, what it's useful for is certain types of theory building and understand the implications of a certain network structure. That's what we're going to use it as a kind of lens to understand different network structures right now. Okay, but we are going to. It's rare that I have a model of some textured external situation where I use that, but I use it quite often to illustrate certain properties. Okay. So, ladies and gentlemen, having settled on a ring network, now what I'd like to do is to do something that we haven't done before. And this is going to push you a little bit, so I apologize. But we're going to go and we are going to put in place a new type of output mechanism here. This new type of output mechanism will be to complement what we've done previously in terms of statistics, okay? And here we are going to put in place a mechanism which is going to display a histogram of individuals who, in terms of the number of connections that they have. So yesterday we introduced statistics. Do you remember that? Statistics to compute quantities? And like the number of people susceptible, number of people infected, the number of people, the average income of people. Do you remember those things? Now we're going to have a different sort of measure. We're going to put in place a histogram. Are we okay? Okay. So, ladies and gentlemen, let's put in place a histogram now. Shall we not? We shall. Okay. So, in order to do this, I'd like to go over to the palette, and I'd like to go down to the analysis tab of that palette. And I would like to pull up two things. The first thing is what's called the Histogram Data, and this will be called Histogram Data. Okay. Great. Okay. So, ladies and gentlemen, we're going to have histogram data. This is going to be some data that as to how many people are in each bin, and then we're going to draw out a histogram here. Okay. This histogram is going to give the distribution of people by number of connections that they have. Are we okay with that? Okay. Ladies and gentlemen, this histogram is going to be called, this chart is going to be called degree histogram. And the histogram data is going to be called degree histogram data. And the degree histogram is going to need to be connected with the appropriate data object. How do you think we do that? Let's look at this degree histogram. How do you think we would connect it up with the corresponding data object? Do you see something that might be at use?
On properties.
Yeah, data. There, add histogram data. Okay, so let's add that in. And we're going to say, degree centrality. For those who are familiar with social network analysis, this is going to refer to the number of connections that people will have. And the histogram here will be degree histogram data. Okay? Degree histogram data. Here we are. Ladies and gentlemen. So we just hitched this up to that, okay? Are we okay with that? Okay, now, ladies and gentlemen, I would like to add one more thing here. And that will be an event. From whence do I find an event? Not from whence. Whence do I find an event?
Agent.
From agent, indeed. Okay. Okay, and this is going to be update histogram event. Okay? So this is going to be where we update the histogram, and we're not going to change any properties. It's going to occur once on a timeout at the time of 0. Are we okay with this? Okay. Now, ladies and gentlemen, steel yourselves. Okay? We're going to add some data into this histogram. Okay? Okay. Ladies and gentlemen, there's multiple ways we could do this. The first thing we're going to need to do is declare the histogram. Make sure no data is in there already. Degree histogram data dot, and you can complete it out, but we're going to do dot reset. Okay? It's going to reset whatever's in there. So sure, we're starting with a blank slate. Okay, and now, ladies and gentlemen, we are going to go through each person in the population, and we're going to add their data in, their degree centrality into this histogram. We're going to go through each person in this population. We're going to sort them into the histogram bins, right? A histogram has bins, right? It's going to count the number of people of these many connections, or that many, or that many, and that many. In order to compute that, we have to go through each person in the population and kind of sort them into these bins. This one goes to this bin, this one goes to that bin, this one goes to that bin. Does that make sense? Okay, now fortunately, AnyLogic does most of the work for us, but we need to do one thing. We need to go through each person population and say, hey, sort this person to a bin, sort this person to a bin. It'll take care of figure out what bin they fall in. Okay? Are we ready for this? Okay, watch this. For person, we're going to call this person, maybe we'll call them P, in the population. For each person in the population, that's what this says, for each person, and there's a colon in the population. Thank you, Kurt, for going on the prowl. Okay? For each person P in the population, and indenting, which is good practice here to show it's inside of this, we are going to do degree histogram data dot add. So we're going to add to the degree histogram. We're saying, hey, degree histogram, add this value into you. And the value is going to be P dot, how do we get the number of connections a person has? Does anyone remember from yesterday?
It starts with get.
Get.
Connections.
Get. And let's start to see, okay, suppose we only remember get connections number. Returns the number of agents. Do you see that? Do you see that? Get connections number. Okay, ladies and gentlemen, that's it. That's it. The deed is done. Let me put it up on the big screen. Okay? So here we go. Boom. That's it. There it is. It stands before you. It's painful, but honestly, it's not that much more painful than a R code. Okay, that's the semicolon.
How many times I wondered, explaining this code.
Yeah, actually, there's cleaner ways to do. I mean, there's sweeter ways to do this in this, and there's sweeter ways to do it in R. You can do this in one line here, and you can do it in one line in R. But I don't want to. It's short and it's sweet, but it might scare you. So I don't want to show it right now. That will be saved till later. I show it in some of my boot camps, but for the math, we'll spare you. Okay? Are we okay with this? Remember, autocomplete is your friend. If you're typing this out character by character, you're putting yourself into a world of hurt. Autocomplete is your friend. Is that right?
Yes.
Yeah. Okay. Do people want this up there a bit longer? Are you ready to run it? You ready to run it? Okay. Who needs a bit more time? Krugerian assistance is available. Okay. Okay, so shall we run this thing? Notice I put that histogram up in mine. There it is. Looks like they're all in 22 there. Okay. So let's go now start to experiment with networks, ladies and gentlemen. Okay? Why was that all 22? Well, they all had 22 connections there. Ladies and gentlemen, I'd like to go down to main and I'd like to switch the type of network. Now, we're going to leave it as a ring, as the ring layout, but we're going to change the type of network. How would I do that, ladies and gentlemen? Can anyone tell me? So I go to main, I've gone down in main to the space and network, and now I'd like to change it from a distance-based network to a random network. Are we okay with this? Now each of these network types is going to have a corresponding structure, okay, and corresponding parameters. So I'm going to do this as a random network with a certain number of connections per agent on average. Okay? We okay with this? Let's make it 5 connections on average per agent. Okay? Okay? So let's say 5, and here we have a 5 connections per agent. Now, what is this histogram showing us up above? Does everyone have exactly 5 connections? No. That's the most common number, but then some have more, some have less, right? By the way, how would I export this to Excel? Can anyone tell me? How would I export this chart to Excel? Export the data under the chart, or the chart for that matter. Anyone know? Right click on it, and I can do copy chart image. That will in fact copy the image here, and I'll do here's my Excel, and I'll copy it to Excel here. There's my image, but I could also do right click on this and do copy all, and this will copy in fact the underlying data. Oh my gosh. On certain versions of Excel, this works.
You can do it.
Oh, yeah.
You just have to click the control thing and.
Sorry,
Paste it again.
okay.
You see the control box? There's a little help box right above where you selected. Down to the right a little bit.
Oh, this guy?
Yeah, click that.
Yeah.
You go use text with import wizard. You specify what's delimiting the text.
So you could just say,
Yeah.
oh, okay. Okay, but that, okay, so even that, okay, let's try that again. Thank you, Kurt. Okay, so looks like we want to do fixed, it's not fixed width. Okay. Okay, that's still not quite right. It looks to me like that there are some versions where it'll paste it immediately in just fine, but it doesn't look like this is one of them. Okay. Yeah, it's is it tab? Okay. Okay, there we go. Ladies and gentlemen, that's how we do it. Okay. Okay, so ladies and gentlemen, what you need to do, let's just do this again. Thank you, Kurt, for the instruction. Okay, so man, I gotta record this separately. Okay, so